Okay, today we're going to do 8.1 equation of circle. This chapter comes in 3 parts, and today will be part 1. Okay, now first and foremost, you remember how to complete the square. So look at these two expressions here first. Okay, then we see how we can complete the square. So now for x squared minus 4x plus 7, you remember that it can be expressed in this form. So plus 7, so what we can get is x minus 2 square plus 3. Similarly for x square plus 5x minus 3, if I express it in the completed square form, you should be able to get this expression there. Let me just calculate that. If you've forgotten how to complete the square, this is a very essential skill for this chapter. Please do check in with your teacher on how to do this. Okay, first and foremost today, what we're going to learn is the equation of a circle. So far, we have learned equation of a quadratic curve, we have learned equation of an x cube graph, then we also have learned, like for example, the equation of a straight line. Okay, so now today what we have, right, is the equation of a circle down here. So basically, if you look here from this diagram, there is a center, there is A and B. So the equation of a circle is given by this. So it's x minus a squared plus y minus b squared. This a and this b actually comes from the center itself. This r is the radius of the circle, and this is known as the standard form of the equation of a circle. Do not be confused. This is nothing to do with the standard form that we have learned. This is basically the equation of a circle. Not to worry. What I can do for you here is this. I will actually go through how we can obtain the equation of a circle through 4 simple examples. So now let's go on to example 1. For example, okay, what we have here is this. A circle with a center of 0, 0 and radius 5 units square. So if I just bring you back to the previous what I call slide there, where we learned that the equation of a circle is x minus a square plus y minus b square is equal to r square. In this case, a is 0, b is also 0. So what we have is x squared, okay, or rather x minus 0 square plus y minus 0 square equals to the radius, which is 5 square. If I simplify, I get x square plus y square is equals to 25. That's quite simple. Now for b, a circle with a center 2, negative 3 and radius 4 units square. So once again, x minus a square plus y minus b square is equals to r square. See, now this here it is 2, so what I'll write here is x minus 2 square plus y minus negative 3. So here what we get is plus 3 square. Because this is minus 3, so y minus negative 3 gives you y plus 3 square equals to r square, which is 4 square. If I simplify, I get y plus 3 square is equals to 16. Also quite simple, I feel. Now this one, it says that this is a circle with center negative 2 and 5 and it passes through the center 0, 0. Maybe I can sketch for you a little sketch, okay, to actually help you with this. So now what I have here is I will draw the what I call the axis here, the x and y axis. Okay, then I can have a circle like this. Okay, it became an oval. Let me try again. Okay, then I will move this circle like this. So basically what they're trying to tell you here is this. There is a center, okay, there is negative 2 and 5 and it passes through the point 0, 0 like this. Okay, now, so first and foremost what we have here is we use the equation of circle again. So I get is x plus 2 square plus y minus 5 square equals to r square. Then we ask ourselves, hey, how am I going to get the radius in this case? So now, okay, radius is basically from the center to any point on the circumference. That will give you the radius r, as you can see from my diagram. So in this case, my radius is equals to, if you remember the formula, okay, for length of a line. So what I get is -2 minus 0 square plus 5 minus 0 square root. So the radius in this case is square root of 29. For those who may have forgotten, I will just write for you the length of a line, okay, is equals to square root of x2 minus x1 square plus y2 minus y1 square, and we square the whole thing. That's the length of the line. So to complete this question, what I can say is that the equation of line is x plus 2 square plus y minus 5 square is square root of 29 square. You just simplify a little teeny bit. Square root of 29 square gives you 29 itself. And that is example 1c. Example 1d. A circle with center -4, -3, passing through the point 2, 1. So it's the same thing again. So I will just write down x plus 4 square plus y plus 3 square is equals to r square. Same idea here, so that we need to actually find the radius of this circle. So the radius is between the point, the center, and the point 2 and 1. So if we just use that, what I can say is that the radius in this case is equals to x2 minus x1. So minus -4 gives you plus 4 square plus 1 minus -3 is plus 3 square root. So I get is 36 plus 16. My radius is square root of 52. So my equation of my circle is x plus 4 square y plus 3 square equals to root of 52 square gives me 52. And that is 1D. Now, what I need you to do is to pause the video and then try 1. Okay, the 4 questions are there. This can be found in your textbook on page 195. Then once you're done, you may unpause the video and then we can actually watch and then can go through the answers to try 1. In 1 more second and let's go. Okay, for 1a itself, if you wrote down this, you apply the general equation of a circle, you should get x squared plus y squared equals 36. Similar for b itself, this one I shall not explain too much. I think that the basic concepts are there. What we need to do now is for part C, same idea here. What I can do is to find the radius of the circle, apply the general equation of the circle, and you get the answer for part C. This is similar to part D, and these are the basics, the very basics that you need to know before we embark on more difficult questions, which we will do in example 2. In example 2, the diagram shows a circle in which AB is a diameter with endpoints 2 and 4. Okay, what is special about the diameter is that if you find the length of a diameter, you divide that by 2, you get the radius of the circle itself. So now, first and foremost, what we can find is that we can find the radius, the diameter first. So the diameter, in this case, is given by, there are 2 points there, 2, 4 and 6, 4. So diameter equals to x2 minus x1 square plus y2 minus y1 square root. If you work that out, you'll find that this will be 16 plus 0 is, diameter is 4 units. Hence, this means that my radius, okay, where is 4 units? Here to here, we have just calculated is 4 units. Hence, this means that my radius is 4 divided by 2. My radius is 2 units. Now, next thing, what is so special about a diameter is that at the midpoint of every diameter, you will find the center of the circle. So from here to here, if I find the midpoint M, this is equals to the center of the circle. So what I can do here is this. If you remember the way to find the midpoint, x1 plus x2 divided by 2, y1 plus y2 divided by 2. This is the way that we can find the midpoint of the line segment. So in this case, to get my center of my circle, what I'll take is 2 plus 6 divided by 2 and 4 plus 4 divided by 2. And the center of my circle is given by 4, 4. I have enough information now to actually start with to write the equation of my circle. So my equation here now is this: x minus 4 square plus y minus 4 square is equals to 2. Don't forget to square this, it's r squared. So I get x minus 4 square plus y minus 4 square equals to 4. That is my equation of my circle. Now in part 2, they ask us to determine if the points 3, 2 and 4, 5 are inside or outside of the circle and explain. Okay, this one not too difficult. So basically it is this. Okay, so now my center, if you remember, the center of the circle was 4 and 4. So if a point lies on the circumference of the circle, so it should be when you find the length between the center at that point, let's say between center and P or center and Q, it should be exactly equals to, in this case, 2 units, because the radius in this question is 2 units. So if you find the length between center and P, center and Q, you can determine if it lies on the circumference of the circle, inside the circle, or outside of the circle itself. So what we can do now here is this. I will just very quickly find the distance, okay, between center and P. So if I use the formula, what I get is equals to 3 minus 4 square plus 2 minus 4 square square root. And what I find that this value is square root of 5. Square root of 5 actually is a value that is greater than 2 itself. So if this is greater than 2, what this means is that this point actually, right, it lies outside of the circle. So hence P lies outside of circle. Okay, similarly, what we can do here is this. Okay, let me just resize this. Okay, now if I want to find the distance, now it's still on part 2, I'm going to find the distance between center and Q. Same thing, apply the length or the distance formula. So what I get is 4 minus 4 square plus 5 minus 4 square. I get equals to 1 unit. So 1 unit is lesser than the radius 2 unit. So it means that this point Q actually lies inside of the circle. So I can make the statement that Q, okay, lies inside the circle, okay, as length, okay, is lesser than radius. The third possibility is when you find the distance between the point and center is exactly equals to 2. When that happens, then it lies exactly on the circumference of the circle itself. Okay, so for try 2, please take some time to attempt try 2, and I'll give you the answers in 3, 2, 1. And here we go, try 2. Okay, now for the radius of the circle, same thing. Okay, for try 2, if you found, okay, the diameter of the circle and then you divide by 2, you will get the radius itself. Same thing, since these two, right, are the endpoints of the diameter, you can actually find the center, which is 0, 0. Hence, if you simplify it, what you will get, right, is this. Same thing as the previous example that I've given you. If you're able to find the distance between the point P to center, point Q to center, in this case, point P is lesser than the radius itself, so it lies inside the circle. Similarly, okay, if you found distance between Q and the center, since the length of this line segment is longer than the radius, so Q is actually outside of the circle itself. Example 3. Okay, example 3, it differs slightly from what your book actually shows you, so please do pay attention. Okay, I'm going to show you how I will actually attempt this question to actually get the center and radius. So first, I will rearrange my equation. Okay, x squared plus 6x, okay, plus y squared minus 4y is equals to 12. Okay, notice that I've rearranged my equation so that I can actually, what I call, push all the variables x right onto the left hand side of my equation. So what I'll get here is this. First and foremost, I will actually say that I will complete the square for x squared plus 6x. Hence, at the first part of this video, I actually asked you if you remember how to complete the square. Very important skill here. So I'll complete the square for x squared plus 6x. So I'll get x plus 3 squared minus 9. So this and this are equivalent. Now I'll deal with y squared. So what I'll do is I'll say y minus 2 squared minus 4. Again, this and this are equivalent. And on my right hand side is equals to 12. So if I start to simplify, this and this is equals to negative 13. So what I'll get here is x plus 3 squared plus y minus 2 squared. You add 13 to both sides, you get equals to 25. I will once again do the same for B. So for B, same idea, I won't use different colors this time. I will just delve straight into the question itself. I've rearranged the equation for part B. So what's going to happen here is this, x squared plus 4x, I group the x terms together. Y squared minus 2y, I group the y terms together. So if I start to complete the square, I get x plus 2 squared minus 4 plus y minus 1 squared minus 1 equals to 95. So what I get is x plus 2 squared plus y minus 1 squared. Then if you notice, okay, down here negative 1, negative, then you go over is 100. So what I get is x plus 2 squared plus y minus 1 squared equals to 10 squared. Okay, I think I believe that I forgot to actually answer the question just now. So I'll answer this one first. I go back to part A to get you the radius and the center of the circle. So in this case, for part B, my center is equals to negative 2, which I get from here, and 1, which I get from here. And my radius, r squared, so my radius is equals to 10 units. Similarly for part A itself, okay, if you look at this equation that I have here, my center is equals to negative 3 and 2. Alright, and my radius is not 25, my radius should be r squared, so my radius is equals to 5 units. Alright? Okay, please try 3, pause the video, go and try this, alright? Make sure that you're able to get these answers here, and I will show you the completed square form for each of them in 3, 2, 1. Okay, for part A itself, if I start to complete the square, I get x squared minus 8x plus y squared plus 4y plus 11 is equals to 0. Here I get x minus 4 squared minus 16 plus y plus 2 squared minus 4 plus 11 is equals to 0. So what I'll get is x minus 4 squared plus y plus 2 squared is equals to negative 20, negative 9, so plus 9. If I rearrange the equation, I get x, or I re-express the equation, I get 3 squared. Hence, my center is equals to 4 and negative 2. And my radius is equals to 3 units. Similarly, for part B itself, let me just quickly do part B. I do it in blue color. Okay, I get x squared minus 10y plus y squared. Whoops, no good, no good. This is not helpful to me. Let me retry this. So what I get is x squared, oh no, okay, plus y squared minus 10y plus 9 equals to 0. So x squared, we just leave him alone, nothing to complete the square. Y squared minus 10y will give me y minus 5 squared minus 25 plus 9 is equals to 0. So I get x squared plus y minus 5 squared equals to 16, which is 4 squared. Hence, for part B, my center is equals to 0 and 5, and my radius is 4 units. Okay, example 4. So example 4 shows a circle that passes through the points 0 and negative 3, and that's point A, and point B is 5 and negative 2. Find the equation of the perpendicular bisector of A. So if we learned in E-Maths, there's this property called perpendicular bisector of chord. So once you have found, right, AB is actually known as the chord, C-H-O-R-D, of the circle. If you find the perpendicular bisector of the chord, you will know that it actually passes through the center of the circle. So there is a reason why this question is structured as such. So if you find this equation of this perpendicular bisector of chord, you will eventually be able to use this to help you to actually find the what I call the center of the circle, which in turn will also help you to find the equation of the circle itself. Okay, but never mind. So now, first and foremost, I have the equation of the perpendicular bisector of the chord itself. So first I find the gradient of the line AB. So y2 minus y1 divided by x2 minus x1. So what I get is the gradient of AB is 1/5. So if you remember from the your time in coordinate geometry, I can find that the gradient of the perpendicular bisector, okay, so the gradient of perpendicular bisector, m1 times m2 equals to -1. So hence in this case, the gradient is -5 itself. Next thing is this, I know that the perpendicular bisector, if you look here, this perpendicular bisector here, this one, alright, it will pass through this point. Here I put in red. This red point is a perpendicular bisector. Bisector means that it cuts the chord AB exactly into two. So this red point here is the midpoint of AB. So if you remember how to find midpoint, which we have found earlier, so the midpoint of AB is equals to 0 plus 5 over 2, -3 plus -2 divided by 2. In this case, the midpoint will be 5 over 2, -5 over 2. If you want to find the equation of the line now, the quick way is you use the point given, midpoint of AB, and the gradient itself. So I will apply y minus y1, okay, which I got from here, and then I use x minus x1, which is 5 over 2, which is this value I got from here, is equals to the gradient itself of the perpendicular bisector, and the gradient is -5. If I just simplify, oops, I run out of space, but never mind. So I get y plus 5 over 2 equals to -5x plus 25 over 2. So if we just simplify all of this, what I get is y equals to negative 5x plus 10. This is the equation of the perpendicular bisector. Is the dotted line, not the green line itself, is the dotted line. Okay, just bear that in mind as we do part 2. So in part 2, they say that there are two lines. The center C lies on the line 3x plus y equals to 0. That's a green line. So what they're saying is this perpendicular bisector and this green line, they both intersect at the center of the circle C. So this becomes a question of solving simultaneous equations. So in part 2, what we have is 3x plus y equals to 0, y equals to negative 5x plus 10. If I just sub 2 into 1, very convenient, we get 3x minus 5x plus 10 equals to 0. Solving, my x value equals to 5 and my y value is equals to negative 15. Hence, the coordinates of my center C is 5 and negative 15. Part 3. Find the equation of the circle in general form. We already have the center, so all we need to do now is to find the radius. Okay, be very careful. Do not find the center to the midpoint M. That's not the radius. This, if you zoom in, it ends here. There's still a bit more distance to go over here. So what you actually want to do is to find the distance between A and C or B and C. I think A and C is better because A contains a 0 there. It makes your life just a bit better. So if I find radius is equals to y2 minus y1, so I'm using A and C. So 0 minus 5 square plus negative 3, negative becomes positive 15 square root. What I get is that my radius of my circle is 13 units. Hence, the equation of the circle, okay, given that the center was 5, negative 15, let me label that 5, negative 15. So equation of the circle now becomes x minus 5 square plus y plus 15 square equals to 13 square. So what I get is x minus 5 square plus y plus 15 square equals to 169. And we are done with example 4. Okay, please try 4, alright, and then we will conclude this part 1, okay, of this video. And I will give you try 4's answer in 3, 2, 1. Okay, for try 4 is this. Same thing as what we have done. You can find the gradient of the line segment AB. Then you find the perpendicular bisector of AB is 2. And just as what I did in my example, I found the midpoint of AB. I used the idea that I have y minus 3 x minus negative 2 equals the gradient of the perpendicular bisector is equals to 2. So y minus 3 equals to 2x plus 4. Then if you solve it, you get y equals to 2x plus 7 as shown here. Okay, now the center C lies on the line 5x plus y equals 0. So just as we had the other diagram, so the perpendicular bisector passes through the center C. Then we have another line, okay, 5x plus y is equals to 0. It also passes through C. So if you use simultaneous equations, you can find the coordinates of C is negative 1 and 5. Lastly, if I use either the point A to C or B to C, I think we use A to C, you can find that the radius of the circle is 5 units. And if you express it as this in the equation of circle, you will get this. If you don't want to expand, I think you just leave it. This is perfectly fine. And this ends part 1, okay, of equation of the circle. And thank you for watching.